So we are working on a problem from our textbook to find the volume of a solid whose base is a circle of radius a and the slices perpendicular to the base are squares. So what we are going to do is, let's take a particular case where a equals 2. That is, we are changing the question to the solid is made up in a way that the base is a circle of radius 2 and the slices perpendicular to the base are squares. So for convenience, let's take the circle as x square plus y square equals 4, circle with center at the origin and radius equal to 2. And let's say we have a point px y here. All right, so this is our x, okay? So if we look at the y coordinate, which will be this length, okay, that will be how much? Y equals square root of 4 minus x square. Likewise, this here we will have y equals negative square root of 4 minus x square. So how much aside of this square would be? That equals this quantity, right? Okay, and then this will be the same quantity. So the area of the face would be 2 square root of 4 minus x square whole square. So that will be 4 times 4 minus x square square. Okay, not a square, I'm so sorry. Okay, so just 4 minus x square. Now, and the thickness, let's take the thickness as delta x. So when we integrate all these pieces from -2 to 2, all these volumes, so this is the area of a face, okay, and then this is volume of a basic element. So this integral will give us the entire volume, okay? So we are going to evaluate this integral, and notice this, that the function that we are integrating, I'm taking only the variable part. If we change x to negative x, the function doesn't change. It just remains as what? As just the original expression. So this is an even function of x. So what we may do is, just to save time, this will be twice the integral from 0 to 2 of the same quantity, because we have an even function of x here, okay? And that is going to be, let me just do the whole integral. I mean, this was not that long a question. So here we can pull our 4 out. That will give us an 8 here. And then what we have is, we have 8 times, okay, 8 times, and then we will do this, just bring the antiderivative in. So that for 4 is 4x, okay, and for x cube, sorry, for x square, I'm talking ahead of myself, we get x cubed over 3, okay, and that ranges from 0 to 2, all right? So here we have 2, and here we have 0, sorry, on the bottom we have 0 here, and so the final value is how much? That will be, the value at 0 is 0, so all that we will have is simply 8 times, okay, 8 times 4 times 2, okay, so here 4 times 2, that is 8 again, and then 2 cubed here, and this quantity equals how much? 128 over 3. So that's the volume of this solid, okay? Now let's just go ahead and use computer to draw, just to see how this solid will look like, okay? So here I have used MATLAB to draw many squares, and you can see that as the squares increase, you can see the behavior through the corner. That is, there will be one side here and one vertically along here. And so they go on increasing and then go on decreasing. Same on this side. All right. And so I don't know what I'm going to call this solid. Okay. But anyways, I'm going to just go ahead and make these squares denser. That is, take many more squares just using MATLAB. And then we will get a better picture of this solid. So here we have, much denser collection of those, and I can make the collection even denser, but let's not worry about it at the moment. Okay, so this is how the solid will look like, and I still can't find a name for this solid. Okay.